Alright, so in this lesson, we're going to talk about what an inverse function is and how we can find it. This study guide is on Google Classroom. It's attached to the same assignment as the agenda. So the first thing here is an inverse function is a function or relation that undoes the work of another relation. So for example, if a function adds 3, like x plus 3, then its inverse is going to do the opposite of that. It's going to subtract 3. So the inverse of x plus 3 would be x minus 3. In function notation, the inverse of this f of x would be written like this. F, the little -1 exponent of x. We pronounce this, when we read this, we say it's the inverse of function f, the inverse function. The -1 here isn't actually an exponent. The -1 exponent is used a lot to denote an inverse. So this just means that we're looking at an inverse of this function f. The next thing is the domain and range. As you know, the domain is all of your possible x values, and the range is all of your possible y values. So the domain of the function is always going to be the range of the inverse. And the range of the function is always going to be the domain of the inverse. So basically what happens is in an inverse function, all of your x's and your y's get switched. So down here, if I have a point in my function x comma y, then in my inverse, I'll have the point y comma x. So for example, if the point 1 comma 5 was in my function, then the point 5 comma 1 would be in my inverse. So how do we find an inverse function? I already told you that the inverse of x plus 3 would be x minus y, but what if it's more complicated than that? How do I get that inverse function? So this is a step-by-step process that will help you get the inverse function for any kind of function, no matter how complex it is. So the first step is to replace f of x with y. So f of x equals x plus 3 becomes y equals x plus 3. And then we're going to swap out x and y. So y equals x plus 3 becomes x equals y plus 3. And then we solve for y, meaning I just need to get y by itself on the left side of that equation. So I can do that by subtracting 3 from both sides of my equation. So I end up with x minus 3 equals y. And then, of course, we change the order of our function because we like to have what it's equal to on the left instead of the right. So we change it to y equals x minus 3. And then for notation, we're going to change that y back into a function notation. And since this is an inverse function, we write it as f inverse of x equals x minus 3. So there we go. The inverse, the function f of x equals x plus 3 has an inverse function. F inverse of x is x minus 3. And the reason why these two are inverses is because they undo each other. So we can use a composition. That's not what I wanted. To check that the two functions are inverses of each other. We talked about compositions quite a while ago. When we take a composition, it means we're going to put one function inside of the other. So if I put an inverse function inside of a function, or I put a function inside of its inverse function and solve, we end up getting x, just x by itself. And we'll do some examples of this. So f inverse of x is the inverse of x. All right, so in this problem, we're going to use that. So we have a function, f of x is 3x minus 9, and in another function, g of x, is x plus 9 over 3. And we want to check and see if they're inverses of each other. So we're going to use that rule above here, this rule. I'm going to make a composition of these two functions and see if that composition is equal to x. And I can do my composition in either order. I can put f inside of g, or I can put g inside of f. So I'm going to do it this way, f of g of x, which means that I'm going to replace all my x's in f of x with g of x, which is this whole thing here, x plus 9 over 3. So the easiest way to write that, I'll write my whole f of x, 3x minus 9. And where x goes, I just put big parentheses here so I can see I have a function that looks exactly like my f of x. And then where g of x goes here, I'm going to put in this function g of x, x plus 9 over 3. And then we're just going to simplify that and see if it equals x. The first thing I notice here is I'm dividing by 3 and I'm multiplying by 3. So those will cancel out, which leaves us with x plus 9 in the parentheses, and then the minus 9 out here. And of course, 9 minus 9 is 0, so we're just left with x. Since what it simplified to was just x, that means that these are inverses of each other. F of x and g of x are inverses. If I had got anything else besides just x, we would know that they're not inverses. All right, here we're going to do another one. Show that this function, 8x squared minus 2, is the inverse of this function. So again, we're going to make a composition, and I can make my composition in any order. So I will do it, I'll do it this way, f of f inverse of x. So I'm going to take my function f on the outside, that's this one, and I'm going to write it with big parentheses where the x goes. So you can see at this point, all that I've written down is this function f of x. It looks exactly the same. I just replaced x with big parentheses there. And now inside of those parentheses, I'm going to put the f inverse function, this function here. And now I just simplify and see what happens. So the first thing I notice is that I have a minus 2 here and a plus 2 here. Minus 2 plus 2 is 0. So I'm left with just 8x squared over 8 in my radical. And of course, 8 over 8 is just 1, so they cancel each other out, which gives me the square root of x squared. And square root and squares cancel each other out, so we get just x. And again, since my result was just x, that means that f of x and the other function, which they actually said was f inverse of x, are inverses. If we had got anything besides x, then it would not be an inverse. So the general rule here, this is basically what we already talked about. To find the inverse of any function, we take the original equation and solve for the independent variable. Okay, in most functions, that would be x, right? X is your independent variable and y is your dependent variable. Now we're going to look at some examples where our independent variables and our dependent variables represent real things. So they put in letters that are not x and y. They put in things like d for distance or t for time. So this function here, I don't really know what p and s represent. There's no context to this problem, but we no longer have an x and a y. I can see, though, that s is my independent variable because I have a function of s. So here's a step-by-step process to finding an inverse function when we don't have x's and y's. So the first thing we're going to do is we're going to replace the function name with the output variable. So instead of having p of s here, I'm just going to write p. Then we're going to solve for the input variable, meaning I'm going to isolate the other variable, s. So I'm going to do that by subtracting 3 from both sides, and then dividing both sides by 2. And then, of course, we like our variable to be on the left instead of the right, so I'll change the order of that function. And then replace it with the name of the inverse function. So our original function was called p of s. So we're going to call it p inverse of s. So let's use that concept to do something that we actually see a lot, and that's the function that converts Celsius into Fahrenheit, and its inverse function which converts Fahrenheit into Celsius. So here we have the function of Celsius in terms of Fahrenheit, which is 5/9 times Fahrenheit minus 32. So this converts Fahrenheit into degrees Celsius. We're going to find the inverse function, which is going to convert Celsius back into degrees Fahrenheit. So the first step is I'm going to change my C of F to just C. And then we're going to isolate the F now. So the first thing I need to do to isolate the F is I need to get rid of this 5/9 that is outside of the parentheses. The opposite of multiplying by 5/9 would be to divide by 5/9. And remember, to divide by a fraction, you multiply it by the reciprocal, which is 9/5. So we're going to multiply both sides by 9/5, which is going to cancel those fractions out. So now we have 9/5 times Celsius equals F minus 32. And to undo subtraction, we just add to both sides. And then we're pretty much done. I just need to put F back on the correct side. And then change it to the correct notation. So C of F is now C inverse of F. And we're done. All right, and that's it for 4.1.